Hello everyone. In this chapter we're going to look at the BIOS, CMOS, and firmware, as well as the way a machine boots up and some of the configuration files. We're going to discuss the differences in BIOS, CMOS, and firmware. We're going to describe the relationship of the CMOS and the BIOS. We'll talk about how to configure the system BIOS. And we'll talk about a process known as POST. POST stands for the Power On Self-Test, and this is something that every computer does when it's first turned on. Then finally, we'll talk about how to update the BIOS through a process that's known as flashing. So BIOS stands for Basic Input-Output System. And basically, this is what starts the computer. The BIOS identifies what's connected, such as the CPU, the RAM. It has instructions for the keyboard to work. Some BIOS will have instructions for the mouse. The BIOS has a small program that will boot up enough for the computer to recognize the CD-ROM to boot to install an operating system. And it includes a basic driver to allow there to be a display of what the settings are. When you turn the computer on, it goes through a process called the POST, or the Power On Self-Test. And the POST is where it tests all the system devices and initializes everything. So BIOS is firmware, and what we mean by that is it's software that comes embedded in its own memory chip. And there are two types of memory used for firmware. There's EEPROM and EEPROM. EEPROM is the older type, and it stood for Erasable Programmable Read-Only Memory. Only older CPUs used or older machines used the EEPROM. And the way that you actually had to erase an EEPROM chip was that you put it in a device that looked a whole lot like a small tanning bed, and it had ultraviolet lights in it. And there's a hole in the top of the memory, and literally you would flash the BIOS. By flash, we meant you left it in there for about 60 minutes, and that process through ultraviolet light would erase what's on it. That's where the term flashing the BIOS comes from. We don't do that anymore, but that's where the term is. What almost everything uses now is called EEPROM, and that's an electronically erasable programmable read-only memory. EEPROM can be erased inside the motherboard and then rewritten as there's a new version of the firmware. So the locations for the BIOS, it varies on different computers. Here we're showing a couple of examples. Look for the battery. It's usually pretty close to the battery, but not always. Usually it's close to that battery because the battery is needed for the CMOS settings, and you'll see that shortly. So CMOS stands for Complementary Metal Oxide Semiconductor, and it is a type of RAM. What that means is that it is volatile. If the power is lost, it loses its settings. The small battery on your motherboard keeps the settings in CMOS. And CMOS is the settings for the BIOS. The settings in the CMOS are changed with what's called the CMOS editor, and that's the BIOS screen when you turn your computer on. So there are different ways to get into the CMOS editor on different computers. On a lot of computers, you hit the escape key. On some, the delete key. On some Dells, it's F10. Control-Alt question mark is on some older machines. Most computers, when you boot up, there'll be a message on what's called the splash screen that'll tell you how to get into the BIOS. If it doesn't display a message, look in your motherboard book and it'll tell you what screen it is for your specific type of BIOS. So some of the settings that are alterable are used commonly are the boot sequence. Default on most machines is the hard drive, the CD-ROM, and USB. Lots of people will turn that to make the CD-ROM first so that if a bootable DVD or CD is in the drive, it'll boot from it. You can change memories here, the memory settings. This is where you also do some overclocking. We'll get more into that, but a lot of overclocking is now done with software inside of Windows as well. Um, this is where you set the hardware monitors as well, like what to do if the computer gets too hot. Sometimes you turn things on and off here, such as PS2 ports or serial parallel or even USB ports. They may have options for USB 2 and 3. If your computer's 3, you might be able to force certain ports to be 2.0 only. You also will tell it about plug-and-play operating systems. Most of those are going to be set to yes by default. You may also have some power management settings there where you tell the machine what you want it to do as far as power management. Again, a lot of these, though, you'll leave to default in the BIOS, and then you'll change them in whatever operating system you're using. So most have a default setting or 3 settings. BIOS defaults, setup defaults, and then turbo. And these are settings that you can set. Turbo usually will be the fastest. Setup default is what they call the optimized settings for your motherboard or whatever you've bought. And then the BIOS default will set everything back to its original. Here we're just showing an example about what the CMOS editor looks like. This one is just an AMI American Megatrends BIOS screen. Lots of motherboards use this one and would have a screen very similar to this. One feature you can almost always count on that you're dealing with an AMI or Dell BIOS if you see this blue background with yellow text. Here they're showing how to see the CPU ID. This one shows the BIOS version and the build date. And here we got an example of how to set up the boot sequence and what orders to set the boot sequence in. So a question often asked are what are integrated peripherals? And those are basically things that are built onto your motherboard. Onboard video, onboard audio, an onboard network card, and USB ports. Almost all motherboards today are going to have at least video, audio, and a network card and USB ports. Some of your higher end ones will come without a video because you're going to disable that and put your own video card on it. But most are going to have network and audio for sure. And there may be external SATA ports as well. This is where you would turn those ports on and off. And the reason for that is that some places for security want those turned off. It's not uncommon, for example, at military installations to turn the USB ports completely off. And the reason for that is so that people cannot use USB memory sticks to copy data onto or off of the machines. Power management can also be configured here. And these are some settings that you can configure, but in general, you may just set your BIOS to one of these and then let your operating system do it. S0 means there's no power management at all. Everything is running at full speed. S1 is power on standby, and what that means is the CPU is off, but the memory is being refreshed. The hard drive is off. S3 is suspend a RAM, and Microsoft calls that standby mode. The PSU is off, but the RAM is refreshed. And it says S0, 2, 4, and 5 are not commonly used. I kind of disagree with that statement because S4 is used on a whole lot of laptops. And S4 is hibernate mode. And if you've got a laptop when the battery gets low, Windows will automatically hibernate it. And what that means is the RAM is written to the disk, and then the computer is completely turned off. And that's done because if the battery's gotten to a critically low state, it's about to go dead. So it writes itself to the memory and shuts down before that happens. Or it writes the memory to the hard drive before that happens. Here you're seeing some of the power management functions where you'll set how you want the machine to respond to a power failure and what kind of power management you're going to set. Here they're also showing an example of virtualization. And this is where you turn on virtualization support that will allow a program like VMware ESX Server to have access to the hardware if it's running virtualization on top of the hardware. So when we talk about CPUs, we talk about a CPU speed, but it's actually a multiplier of the clock frequency. We really shouldn't use the word speed because that indicates something's moving, and a faster CPU, I mean, the fans are moving faster, and I guess electricity is moving through it faster, but the CPU itself is not moving faster, if you will. A question gets asked about overclocking. Should you overclock or not? And that is up for debate. Lots of places will tell you that it's fine to overclock a little bit for games or for certain things. But if you're going to overclock your machine, it's a general rule that you're going to need bigger fans or you're going to need some sort of liquid cooling and you're going to need a better power supply to handle that. So some of the error codes that happen are beep codes. And beep codes generally are error codes where the motherboard cannot display anything on the screen. If it can display a message, it's normally going to show you what's wrong with the computer. But three things that cause there to not be a message displayed on the screen are the CPU, an error with the memory, and an error with the video card. And there are different beep codes for different things. You need to familiarize yourself with those. If you do a Google for standard post beep codes, you'll find what the differences are in a long code and a short code. Make sure you familiarize yourself with those. You may see them on the exam. So another common question is, does your BIOS need an upgrade? And the general rule here is usually you don't upgrade the BIOS unless you need to for a specific reason. They like to say if it ain't broke, don't fix it. What we mean by that is if everything's running fine with your BIOS at the version it is, don't upgrade it. Upgrading the BIOS puts your motherboard in a somewhat vulnerable state in that if you have problems, you may render your entire motherboard useless. So unless there's a reason, don't. Now, having said that, there are lots of valid reasons to need to upgrade the BIOS. In the last computer that I personally bought, I bought a processor that was faster than the motherboard would support, but there was a BIOS upgrade that would allow it to support the faster speed. So as soon as I got it and got it booted up, the first thing I had to do was upgrade the BIOS. Otherwise, my processor wouldn't run at the full speed that I purchased. So before you do a BIOS update, back up all your important data. Something they make a suggestion of that I think is an excellent idea is take a picture of the BIOS screens with your camera. Almost everybody now has got one of these smartphones that's got a camera on it, and it takes just a second to take a picture of those settings. If you don't do that, you might lose the settings when you update, and you'll never be able to get them back unless you can remember them all. So it's not a bad idea to just write all those down. Download the update software. Most vendors now provide an exe file that requires minimal effort. In the old days, you would boot up off of a floppy disk in order to update the BIOS. It had to be done outside of Windows. But most systems now come with a Windows exe that will upgrade the BIOS. For those that don't, most of them come with a download that you can make into a bootable DVD that will boot up off of the CD or DVD-ROM drive and install the BIOS. It is highly recommended that the PC be plugged into a UPS. Now that's not always possible, but the reason for that is that power interruption during a BIOS upgrade can make the entire motherboard unusable. If you've got a UPS plugged in, great. If you don't, just be careful. Don't do a BIOS upgrade in the middle of a storm or when you think the power might go out. Because just for the few seconds it takes to do that upgrade, your computer is very vulnerable. So things do go wrong, and when that happens, you will have to go back to your old BIOS. Now, luckily, some newer motherboards have two BIOS chips. They have one that can be flashed and one that contains the original BIOS to the motherboard. I'm lucky my motherboard has one of those. If I flash my BIOS and my computer fails to boot 5 times in a row, it will automatically copy the BIOS from the original non-writable piece of memory over onto the EEPROM and then reboot. Another thing that happens, some motherboard manufacturers put a write protect jumper in there that keeps you from writing over the BIOS. So in order to write to the BIOS in those computers, you have to remove that jumper. Also, sometimes the video will not work when you upgrade. On some that have the write protect, they will not boot when they're in non-write protect mode. So you have to take the jumper off, flash the BIOS, then put the jumper back on before the computer will work. And if all else fails, if your motherboard doesn't have any kind of backup like that and the flash doesn't work, you might be able to obtain a new flash chip from the motherboard manufacturer. However, some of them are hardwired onto your motherboard, and what that means is if you flash and it doesn't work, the motherboard is going to be useless. So in summary, we talked about BIOS, CMOS, and firmware. We talked about some ways to configure the BIOS. We talked about self-test, and we learned that flashing is something you can do to update the BIOS, but only do it if it's necessary for some specific reason. Thanks for watching.